Thank you very much, Heidi. As I start, I think I will just share my screen. Can you see the slides? Okay, perfect. Thank you. So hello, everyone. And thank you for joining the symposium on the ManyBabies projects 2, 3, and 4 results and lessons learned. So my name is Anna Krämer, and together with Tobias Schuwerk, we are presenting on behalf of the ManyBabies 2 consortium our project, our partially puzzling results, and some challenges we faced. ManyBabies 2 investigates theory of mind. So theory of mind is the capacity to represent epistemic states, like what someone perceives, knows, thinks, or believes. And this is extremely important for our social lives. For example, if I want to predict what someone will be doing next, it is very helpful to take into account what this person knows of the world or believes. And one widely used paradigm to investigate this capacity to represent others' beliefs, especially false beliefs, is shown in this comic here, where Max puts his chocolate in the green cupboard and then goes out to the playground. And while Max is away, his mother comes and transfers the chocolate from the green to the blue cupboard. Then his mother goes out into the garden and Max comes back for his chocolate. Where will Max look for his chocolate? So to answer this question correctly, one must be able to represent Max's false belief about the location of this chocolate. And as meta-analysis showed, children at around age 4 are able to do that. Okay. But then people started using more infant-friendly and non-verbal measures like anticipatory looking or looking time in response to evaluation of expectation and interactive tasks. And in these non-verbal tasks found that younger children and even infants below the age of 2 years are sensitive to another person's false belief. The problem with that is that other projects, again, using these non-verbal measures, have run into difficulties replicating these findings with partially non-replications or partial replications, or also sometimes finding the original results. So overall, the empirical situation is very mixed. And that's why a couple of years ago, many researchers from multiple theoretical camps came together, also researchers including authors from the original studies and non-replications, and wanted to get to the bottom of what's going on with infant theory of mind. We started ManyBabies 2, and as of today, many, many more have joined our project. We decided to, in a first step, start with anticipatory looking, because first of all, it's very easy to standardize. We can make video stimuli that each lab uses the same stimuli. Eye tracking data would be analyzed centrally, which was not that easy, but doable. And another big advantage is that it can use with a broader age range, not only infants of a wider age range, but also adults, which we also did. We then also decided to do a conceptual replication. So we based our new developed video stimuli on materials from previous studies. And the videos we developed looked like this. So just, can you also hear the sound of the videos? Nope. Okay. Do you know how I can share the audio?
Yeah, or it's fine without, I would say.
It's fine without. Okay. It's anyways a bit annoying. Okay. So what we have here, the scene, these boxes are basically the green and the blue cupboard. The bear is Max and the mouse is kind of the chocolate. The mouse enters this Y-shaped tunnel and exits on one side. The bear sees that, the mouse jumps into a box, and then the bear follows the mouse. Also exits the tunnel, knocks on the door, and the mouse hops out again. So this was the familiarization trial. This was showed to familiarize the viewer with the scene, the overall setup, the agent, their goals, etc. For the test trials, we then decided to not jump in and start with a false belief task right away, but instead test a more basic epistemic state, namely knowledge and ignorance. And the ignorance condition looked like this. Here again, the bear and the mouse were playing in the beginning with each other. And then the mouse again enters the tunnel, but this time the bear goes to the back. So it's with the back to the scene and doesn't see anything. When the mouse comes out of the tunnel, jumps into the first box, and then jumps out of the box again, changes location to the other box and hides there. Then the bear goes back, not knowing where the mouse is, enters the tunnel. And here, after 4 seconds, we stopped the videos and looked at where the participants were looking. So we measured their gaze. The knowledge condition looked like this. Again, the same play in the beginning. And then the mouse enters the Y-shaped tunnel. But here the bear looks at the mouse and sees the mouse jumps into one box. To match the ignorance condition, the bear also goes to the back in the knowledge condition, but immediately returns. And then also sees how the mouse jumps out of that box, changes over to the other side and hops into the other box. The bear enters the tunnel again, and we measured where participants were looking. And what we expected to see was for the ignorance condition a bit less clear, as the bear is not aware of the location of the mouse. Gaze could be at both tunnel exits, expecting the bear to exit the tunnel either on that or on that side. Whereas for the knowledge condition, predictions were pretty clear. We expected participants to, as the bear knows where the mouse is, also expect the bear to follow the mouse, so the gaze should be at that tunnel exit that is highlighted here in yellow. The experimental setup was the following. We started with a calibration and 4 familiarization trials. That was the video from the beginning. And then participants saw either an ignorance test trial or a knowledge test trial. And then as a second test trial, the respective other condition. But the main analysis focused on this first test trial. So it was a between subjects contrast, ignorance versus knowledge in the first test trial. This experiment was done in 37 labs across 21 countries and 4 continents, and some more than 800 toddlers and more than 800 adults participated. And the final sample after exclusion consisted of 521 toddlers, aged 18 to 27 months, and more than 700 adults, aged 18 to 55 months. But before we tell you the results, first, quick short time for a big shout out to all the people involved in this project, and some who were especially involved and very helpful for the coordination and analysis. Without these people and many others, this would not have been possible. Yeah, so I think here, Toby, you will take over, right?
Yeah, but could you continue to share the slides?
Of course, yeah.
And maybe you have to maybe you have to be my mouse cursor. Let's see how it works. Jumping to the results, what you can see here is anticipatory looking. So in this 4 seconds phase Anna described, where we wanted to familiarize them with the scene and to anticipate where the bear will reappear according to where it should reappear. And I will only briefly talk about this. This shows you that overall it worked fine. To understand this, the top panel shows, so we have 2 dependent variables. One is the first look, and the second one is the proportional looking score. First look means where did they direct the first look after the onset, so in this anticipatory period. And proportional looking score is where did most of the looks for most of the time land in this whole 4-second period. So they two different perspectives on the same conceptual dependent variable, namely where do they look in anticipation of the action. Everything that is above this dotted line, this 50% line, means basically they got it. So they looked to the correct location where actually the bear then reappeared to find the mouse. So here you can see familiarization worked both in adults and in toddlers, some up and downs, but overall it's above 50%, so it's fine. And that's really important because there were some previous studies who in which it wasn't even found that they, in this familiarization phase, look where the action will happen. So if we now look to the test trials, the most interesting thing here is what you see again on the top, what the adults did. And if you recall the predictions, everything above this line means fine, they got it, and below or a chance means they didn't have a certain looking bias towards the correct or to the incorrect tunnel exit. What you can see here in blue is the knowledge condition, so the bear knows where the mouse is. Accordingly, they should expect the bear to do the most rational thing, namely reappear at the tunnel exit on the side with a box where the mouse actually is in. And that worked. So adults looked, and yeah, not so much in the ignorance condition, as Anna said. We predicted it could have been at chance level or below chance level, but the most important thing in these Bayesian mixed effect models we fitted here is the difference between the knowledge and the ignorance condition. It's really great that you do so much mouse movements, Anna. Thanks. And basically the same in the proportional looking score. So what did the toddlers do? We were quite shocked here because there the pattern of results was flipped. We found a condition difference, but in the opposite direction, opposite as predicted. They had a really strong looking bias in the ignorance condition, so where the bear doesn't really know which tunnel to take because bear doesn't know where the mouse is, but there they had a strong looking bias towards the location where the mouse is. And not so much in the knowledge condition. We have to say, if we look just at the knowledge condition, it is significantly above chance, but this is also partly because this is a huge sample and it's really easy to get significant results here. So one could say they got it right in the knowledge condition, but what is really puzzling is this flipped pattern of results. So when you go to the next slide, we were trying to find out what is going on here. And in previous studies, the familiarization phase was really crucial. And for example, some studies only included toddlers in the test phase analysis who got it right in the familiarization phase. So we were trying to find out whether there is a link between looking in the familiarization phase, correct looking in familiarization, and looking in the test trial. We did 3 different approaches. This plot you can see here is from the last approach. To briefly sum it up, we found some relation, but not really convincing. So overall, in the adults, there was no systematic relationship between. So a positive correlation here would be that a stronger looking bias in the familiarization phase goes along with more correct looking in the test phase. This was not the case in adults. This looks like to be the case in toddlers, but this was a really weak effect only for the knowledge condition and could not really explain, especially with the other 2 approaches we took. So it's not the case that there are some toddlers who get it in the familiarization and they also look correctly in the test trials. So this is not the story here. Something else is going on. So this didn't really help. I mean, the results helped, but it didn't really help us to explain this pattern of results. If you go to the next slide, and just start the videos, what you can see here also for visualization. So this is looking data of all but included participants. On the left side, the adults, on the right side, the toddlers. And we were trying to find out what is going on before this anticipatory phase. What you can see here is that they're really nicely following the plot of this short scene. And what we found here was puzzling. Now in that phase, there's a lot of looking, you can see it later. Maybe if you saw a difference, you can make a guess. If not, the next slide shows you a still frame. So the idea was it might have been that they did not really track the epistemic state of the bear correctly. So when you track beliefs, you usually continuously check what does the bear see, what is the state of knowledge of the bear in every situation. And during this change of location, so where mouse goes from A to B, we so descriptively saw that toddlers are not really looking at the bear so much, but adults on this left screenshot here, you can see there was a lot of gaze at the bear and the mouse and back and forth. And the top panel, you can see here on this plot that there was actually a big difference between what you can see here is a plot of the gaze shift. So number of shifts between mouse and bear in this phase before. So a lot of gaze shifts in adults, not so much in toddlers. So it really, you can see it also statistically, less like checking those two characters in toddlers. These left plots here were then the second follow-up question. Do those who do more gaze shifts, more checking also anticipate more? This was only the case in the knowledge condition for the adults, but not in the other conditions. So it looks like that this might be something. So adults who track this back and forth, what does bear know, also anticipate more correctly, have a stronger looking bias in this knowledge condition, which makes sense. Doesn't really make sense in the ignorance condition because bear has left the scene. Yeah, but in the toddlers, this also didn't explain it in a way that those who did more gaze shifts anticipated more correctly. But overall, they had very lower rates of gaze shifts in total, so this might be an explanation for that. Okay, so this is where we're at. We wrote this up, resubmitted the resubmitted the manuscript, the registered report. Here's the link to the preprint where you can look at all those analyses. And Anna, was the plan that you try to sum up those next steps? Or should I do it?
You can also do it. I mean, however you prefer.
You take over.
Okay, I take over. So the next steps. Right now, we are waiting for the reviews of our registered report. And then we want to tangle basically these questions. So why do toddlers show no clear correct looking bias in knowledge, but instead a greater looking bias towards the target and ignorance condition? And also, as adults, anticipatory looks work quite nicely for the knowledge versus ignorance contrast. Do adults show a belief congruent looking bias in a false belief versus a true belief condition? So in other words, with the adults, we will continue testing a false belief, true belief contrast. But for the toddlers, we kind of went back to the drawing board and we'll do some follow-up experiments to try to explain and improve the existing knowledge and ignorance conditions. And we had a couple of ideas here. For example, there was these 4 familiarization trials. So the knowledge trial was then always the fifth test trial. Maybe it was that it was just too many knowledge trials in a row. So if we show, and the first familiarization trial, toddlers anticipated amazingly good. So we thought that we just cut the familiarization completely and then see how they do if they just see the test trial. And we also want to implement ignorance in a different way. So we need the change of location. This needs to stay there, but we could also work with an occluder. And this is what we are trying to do next for the ignorance condition and then a matched knowledge condition. But we will also try another knowledge condition in which the mouse changes location, but the bear just stays there and observes everything to make sure that it is not the change of location of the mouse as a difference to the familiarization trials that results or that causes this decrease in correct anticipations. No. So that's the next steps. Thank you very much. I think that's it done.
Thanks.
From our side. Or do you want to add something, Toby?
No. Great, thank you. Thank you both. I think we have time maybe for one question if anybody has like a a question about any of the results they presented. Otherwise, yeah, Kylie, go ahead.
Thank you. This was great. And forgive me that it's been a little while since I've looked really closely at the results, so I might just be talking about things everyone is already talked about and bored with. But I'm wondering about you said it is independently significant in the knowledge condition. But that, it's easy to get a significant effect with so many participants. And so clearly if it's an effect, it's a very small one, right? And that, is potentially problematic. But then again, like if we didn't have the ignorance condition, what would we be thinking here? Is one question. But the other question is I'm just trying to make sense of why they're doing so quote unquote well in the ignorance condition. And I'm wondering like how sensitive are our eye trackers to the difference between where the end of the tunnel is and the box. And again, like this might be so obvious, but is it possible that in the ignorance condition, they're just kind of like ignoring the bear entirely and just looking for where they think something's going to happen, i.e. the guys in the box, and that's the best place to look right now?
Yeah, thanks. So these are all important and good questions. And so maybe start with the eye tracker. So it doesn't make a difference if we look at a big area of interest that includes everything, so the tunnel exit and the box. We get the same when we take the more conservative area of interest, which is just the tunnel exit, because this relates to your other question, looking to the box when the mouse is in the box and we anticipate it might jump out of it. That's kind of obvious, but nothing we are after. We really want to measure this action anticipation of the bear's goal, which is take that tunnel and reappear there. So the effect of the bear they are expecting and not of the mouse. And yeah, this is a very straightforward explanation for the strong looking bias in the ignorance condition. It makes a lot of sense to look at this side because nothing will happen at the other side, and the bear, it could be. And if we didn't have the ignorance condition at all, I don't know, we could have been more happy, maybe. Anna, could you go to, what is it, slide 25, where you can see the time course plots? This might help a bit to explain why this is really puzzling. So what you can see here on the adults, so bottom left in the knowledge condition, and the solid lines are the first test trial. We can just look at this or also look at the second test trial. So there is a clear difference between this greenish and the purple line, which is fine. And this difference gets even bigger in the second test trial. So when they learned what is going on here, so that's super fine, clearly as predicted. And then when you look to the right side, to the toddlers, this is very wiggly and fuzzy. And it's really, it might be quite a stretch to say that they got it here in that condition. Whereas here the contrast with the ignorance, this looks pretty clear, but it's the other way around, and this is something we have to follow up. We have to follow up. So that's the most puzzling part, and we just can't really tell. Whereas for adults, it's fine, and I'm really happy that we can take finally the next steps, at least with adults, and go on with testing actually false belief tracking. And with toddlers, let's see. So I sincerely hope that our conditions, our manipulation was just too puzzling with the bear and that door and whatever. Let's see. What makes me confident is that familiarization worked fine. And basically, familiarization is a very simple knowledge trial. And this is what we are trying to, in this one follow-up experiment Anna mentioned, we tried to construe a very simple, the most basic form of a knowledge condition to see whether we find clear results there. which might help. And ignorance is just control. We don't need this condition at all. If this is just strange and we get clear results in another contrast, it's fine.
Great. Thank you so much, Anna and Toby. I'm sure we'll have plenty to discuss in the Q&A at the end of the symposium as well. But for now, let's move on to MB3, where we're going to hear from Catia about what they found there. Go ahead.
Okay, so can you hear me properly? Yeah, so my name is Catia and I'm today presenting on behalf of the ManyBabies 3, and Ingmar will join us for the discussion, hopefully. So today I'm aiming to present the results from the ManyBabies 3, which focus on the replication of algebraic rule learning. So for those of you who are not familiar with rule learning, this ability is thought to be essential for cognition and for language learning, whereby children may use this mechanism to start understanding some patterns that may emerge in their environment, either speech or visual, experiential, etc. So one very seminal work that has been published is the one by Marcus in 1999, which we aim to replicate in ManyBabies 3. And this study aimed to look at algebraic rule learning, which tests the ability of infants to do symbolic manipulation. So this study entailed two main phases, one looking at training, where children, similarly to the study that we just heard, were first familiarized with 2 minutes of sequences of syllable triplets that had an underlying pattern that was either ABA or ABB. And then at testing, they were confronted with novel stimuli that was either consistent or inconsistent with the pattern they were familiarized to. So if a child encountered ABA rule during familiarization, then an ABA novel syllable triplet was consistent with the rule they had just learned. But if they were encountering ABB trials, those would be considered inconsistent. So we had those two trials that would allow us to look at the difference between their looking times, and that would be an indication of rule learning. So what they found in the original study was a very large novelty effect, where 15 out of the 16 infants were showing this preference for inconsistent patterns. So something that was unlike the stimuli that they had been familiarized to. So this was thought at the time and for a long time to show that infants can use symbolic manipulation to infer the structure of input stimuli. So why were we focusing on replicating this study? There's so many replications that could be something that we focus on as part of ManyBabies. We thought that this study in specific was very important because not only has it been a cornerstone in infant learning, infant language development, it has been highly cited, but there's been some more recent work from meta-analysis, for example, that have shown that there's been quite a large heterogeneity in the reported effect sizes. And when they looked at the overall effect sizes, it tend to be smaller than the original effect. There's also been this very close replication by Giambasser, I'm sorry for mispronouncing, and they found no evidence of rule learning in a much bigger sample. So this led us to question whether or not children do show this ability to have this ability to abstract some rules from their environment. So we wanted to tap into both the magnitude and the variability of the rule learning effect in infancy, but also we wanted to understand if this was modulated by age, by the experimental paradigm, their linguistic background, and also whether the rule learning was facilitated by the repetition, for example, if they encountered ABB in training or test items, as there's been some research suggesting that this is indeed an important factor that we should consider, and that may help explain some of the heterogeneity that we found in this meta-analysis. So Our study is not an exact replication from Marcus' study, as we had to make sure that the simile was suitable for children that were coming from different linguistic backgrounds. So whilst the original study was geared towards English acquiring infants, it sounded very robotic. It had been created using Bell Labs synthesizers, and it was a male voice and contained some possibly confounding intonation contours that would allow for more information than just the simple probabilistic information of the stimuli. The syllables also had different lengths, and there was not a lot of variability in terms of phonological features, which we need to take into consideration when then looking at the results. Our stimuli, on the other hand, was aiming to be more universally interpretable, because a lot of children were not from English speaking countries, or if they were, they could be from a more multilinguistic background. So we selected the sounds based on the World Atlas of Language Structures, and then asked participants to judge whether the syllables were adequate based on their own experiences on Amazon Mechanical Turk. So we use natural speech, a male voice, and manipulated in practice to avoid confounds. And unlike the stimuli adopted by Marcus, it was more variably in terms of phonological properties. So in terms of the syllables that we used here, as you can see in this table, we used different syllables training a test. The only thing that was consistent was the structure, so ABA and ABB. So in terms of the procedure, we try to keep it as close as possible to that of Marcus. So we adopted a 2-minute familiarization of 16 unique ABA or ABB sequences, which were repeated 3 times. We had in total 12 test trials with 4 test sequences that were repeated 3 times each, and they were randomized across the blocks. They also started in a counterbalanced way, either with a consistent or inconsistent trial with familiarization, and the look-in times that we measured were at the trial level, and we placed as a rule that a minimal valid look-in time had to be 1 second. But I can talk about some of the decisions we made in terms of robustness to check if this decision made an impact on the results. And labs had the choice of picking between 3 separate paradigms. They could even they could use a head turn preference procedure, central fixation, or eye tracking. So we had various labs contributing to each of them, and one of the labs contributed to both central fixation and eye tracking. So we were very lucky that 30 labs contributed data, and in total we had 877 participants. After a lot of cleaning and data validation, we were left with 839 participants with ages between 5 and 12 months. And there were various exclusions based on predefined criteria. So they shouldn't be preterm. They had to be within the age range that I just mentioned. Also, we wouldn't include participants that had equipment, experimental error, etc. So after all these exclusions and trial level exclusions as well, we were left with 660 participants that were entered into the analysis. So this was quite a good number of participants. And when we looked at actually the number of participants that had 12, also the total number of trials as valid, it was a high chunk of the participants. So 395 participants managed to have all the trials as valid test trials. And this resulted in 7,390 trials in total. So like the previous study, we had a well-powered study, in my opinion. So our main research question was, where are the magnitude and the variability of the rule learning effect? And we observed that there was no rule learning effect, or at least we didn't find any evidence of this, both for different, whether they were being presented with different memorization, ABA or RBB. And this was, I haven't added to the slides, but we also looked at the base factors, and they were very strong at supporting the null hypothesis. We then, because we were interested in seeing this is the effect across everyone, across all participants, what if we are subsetting by lab? So doing a mental analytical approach and looking at each lab and seeing, is there any lab that actually shows an effect? And we see quite a consistent pattern where just one lab shows an effect, which is quite a robust story, I think. We also wanted to know, is even though we don't find this overall learning effect, could it be that there's an effect that is being somewhat obscured by the different ages that we are including in this data set? And that is not the case. So there is no difference between participants based on the age on their learning effect. So it doesn't seem that any of them learned no matter what age they are in our study. We also look at the experimental paradigms. As I mentioned before, we had 3 paradigms, so central fixation, eye tracking, and head turn preference. And as again, this is a very repetitive story, I apologize, but we also didn't find any effect here. There was no rule learning effect across all the paradigms. And again, the story is similar here, independent of whether they are in a more multilingual environment or not. That also didn't seem to affect whether or not they display this different looking time towards the different trials. So because we found so many null effects, we wanted to make sure that the things that we were certain about were present. So we wanted to make sure that we would still find some habituation. And this was something that would give us at least some certainty that the experiment is still working to a certain degree, but the rule learning is just not emerging. And we find that across time, participants are engaging less with the trials. But yeah, we don't find that the rule learning effect even emerges in the first couple of trials, which was something that could have happened, as Tobias mentioned, that it could be that there's some disengagement over time or something like that, or fatigue. But yeah, it doesn't seem that that is something that explains it either. So in terms of the summary, we find no significant rule learning effect. There's no, so just to clarify what I mean by this, in terms of the analysis, there was no significant difference between the looking times towards the consistent and inconsistent trust trials. And we find very strong evidence for a null effect. When we do the follow-up analysis of the individual labs, again, we only find some evidence towards there being a rule learning effect in one of the labs. So 30 out of 31 point towards the null. And we also did plenty of robustness checks that I don't mention here in terms of all the analytical approaches that we took. So for example, we would constitute a minimal valid looking time per trial, what would be the minimal number of trials. And again, the pattern is very consistent that we don't find evidence for a rule learning effect. So for those of you who are interested in learning a bit more, we have now a preprint. And this goes into a lot more detail about all the robustness analysis that we've done, also the moderating factors, and yeah, again, no significant results there. So in terms of the interpretation, as I said before, we try to keep the procedure as close to markers as possible because we thought that was quite important, and only change the things that we thought were a requirement, given that we wanted to expand beyond English-speaking countries and families. So we thought maybe the familiarization is just too short and our stimuli is too hard. By chance, we had a lab that did double the familiarization. So instead of doing 2 minutes, they did 4, and we still find no results. So just by chance, that we obviously know that it's only one study and a small sample compared to the full sample, but still similar in size to that of markers, and we still didn't find a significant effect. And we did find that have all these robustness checks that we did in the beginning to make sure that the syllables that we picked were feasible across various multilingual experiences, but we still didn't find an effect. So we thought maybe rule learning is just too hard, even though we have all this literature suggesting that this is the mechanism, one of the mechanisms that we use to learn so many aspects of cognition and language. So we thought this could be it. But when we look at the age effect, the absence of the age effect, we possibly can't use that as an explanation. When we look at, as well as at the results of MB3, which is the test-retest reliability segue, we also don't find this evidence for test-retest reliability. So it just creates this very consistent story that for now, at least, it doesn't seem that we are showing a lot of robustness in terms of this rule learning effect in infancy. Could it be that looking time as a measure, like the previous team just mentioned, is just not a very sensitive measure? And so for this, we are now seeking out other avenues that can be maybe a bit more, can maybe tap more into these inherent responses that are not as reliant on looking times. So for example, the pupil size and FNIAS, and looking at whether those could potentially talk more about the mechanisms that are underlying their actual processing instead of more behavioral responses. So in terms of discussion, I think this is something that will come up when we bring it back to everyone. We find rule learning to be almost non-existent in our study. I think it is important to consider what are the implications of this study. If it is indeed that we don't find in this control environment, does it mean that it extrapolates to other environments, or is it that children are indeed able to do this rule learning abstraction, but they also are requiring other types of cues that may facilitate this process? And it is also possible that there were false positives in the past, where, for example, the Marcus et al. Had much smaller samples. For example, we know that they had other types of cues, for example, the different lengths and syllables, some confounding intonation contours. It could be that was driving the effect and not necessarily the rule that was underlying it. And there are also broader issues that can always talk about. Replications always bring this discussion about how close are you in terms of the procedure, all these technical and equipment errors, the dropout rates, inclusion, exclusion criteria. So how much of this could be explained the results? But again, like I mentioned, we had so much into consideration of all these robustness analysis or multiverse analysis. So it's a bit difficult. I think in some ways we are so much trying to explain why we get these null results, defend the null results. But maybe we have tried so many things that could possibly show the opposite pattern with the sample size that we have. So I think maybe we should start to believe it, even though, it's been such a hard, such a built up to believe that this is the core mechanism. But if it is not, maybe it's nice to explore other potential mechanisms or think about how they interact with other skills. I think this opens the floor to many interpretations, which is a good state to be, even though I think some might be disappointed by these results. And that is it. I want to thank everyone in our team, especially Ingmar. He's been, an amazing person leading this team. I don't think the preprint would have been sent, at least this early, without all his hard work. So thank you, a huge thank to him, and also to all the participants, of course, for enduring all these somewhat boring experiments. So huge thank you to all. I don't know if you want me, Heidi, to keep the slides up, or I can also take it down. It's up to you.
Yeah, you can stop sharing. Does anybody have a question for Catia or Ingmar, specifically about MB3 before we transition to our third talk? Again, we'll have plenty of time to discuss. Okay, so if nobody has an immediate question right now, you can think about it and ask them at the Q&A at the end of the session. So we will move on to our third and final talk of the symposium, where we'll be hearing from Kelsey Lucca about MB4. Go ahead, Kelsey.
Can you hear me okay? Yes. Okay, great. Well, thank you so much, Heidi, for organizing. And I think there are going to be some consistent themes in my presentation. So I'm excited to talk Babies 4. So I'm presenting today on behalf of the whole ManyBabies 4 team. Like ManyBabies 2 and 3, this was a big team effort. And so these are co-authors on our project. We published the paper, so it's almost its 1-year birthday. So happy birthday to ManyBabies 4. I co-led this project with Francis and Kylie, who are here with us today. So a big thank you to Francis and Kylie and all the labs all around the world who helped. So this was a lot of fun, and I'm really excited to get to tell you a little bit about why we did what we did and how we did it, what we found, and what we're doing right now to keep moving the project forward. So a little bit of background, we know that evaluating others' actions as good or bad is a really fundamental aspect of human nature. And a big question for philosophers, for psychologists, has been, when does this sense of what's right and what's wrong emerge in development? Where does it come from? How does it develop? And in pursuit of this question, in 2007, Hamlin, Wynn, and Bloom published a study in Nature that suggested that this ability to evaluate the actions of others emerges by around 6 months, much earlier than previously thought. And so what they did in this experiment was they showed these events where there were helping events happening. So you see a triangle push a climber character who's trying to get up a hill to help the climber reach their goal. And then they see hindering events where there's another character who comes down and thwarts that climber from reaching their goal by pushing them to the bottom of the hill. They showed them this in alteration over and over. And then after seeing these events, after habituating to these events, they gave infants the choice to choose one of the two puppets. They say, which one do you like? And what they found was that 6-month-olds and 10-month-olds reliably chose the helper character from those puppet events that they saw. So they saw those puppet shows, and then they actively chose the one who helped over the one who hindered. And what was really important about this study was that they did a series of controls. So there were 4 experiments in this original study, and they did a bunch of really nice controls showing that it's not something about babies liking things that move upwards versus downwards. So the key control that they had in this study was that they removed the googly eyes from the climber character. And so what happens now is there's a triangle or a square who pushes a ball down a hill or pushes a ball up a hill. And what they found is that when they remove the social elements from the puppet show, that babies are at chance. They no longer show a preference for one who pushes up versus pushing down, which suggests that babies are really attending to the social components of the events. And not surprisingly, people were really excited about this finding. They still are. It's been cited a bunch of times. So I took this screenshot this morning. It's been cited over 2,000 times. The original findings and subsequent follow-up studies have been featured in the popular press and the media. So if anyone's seen the Netflix show Babies, they feature this finding and other findings. So it's gotten a lot of attention, and it also more broadly sparked a line of inquiry into the nature of infant social evaluations and sociocognitive abilities more broadly. So it was really, just like ManyBabies 2 and ManyBabies 3, really foundational, really a cornerstone project that spurred lots of follow-up studies and findings that then, so people have tried to replicate it since 2007, and there have been mixed results. So some have been successful in replicating, others have been less successful in replicating. And in 2018, Margoni and Surian came out with a meta-analysis where they looked at lots of different studies that have tried to find evidence for infant social evaluations across a variety of different pro-social settings. So I talked about helping versus hindering. Others have looked at fairness or not acting unfairly. And what they found was across all these different studies, 26 different studies that they pulled in their meta-analysis, the average effect size was 0.64. So that means roughly 64% of infants are preferring a pro-social character over an anti-social character. And that gave us some insight into the robustness of the effect, but there were some remaining issues. So nearly half the studies in that meta-analysis were from a single lab with small sample sizes. So about 16 infants are per study. So we need larger studies with higher lab diversity. It raises questions about what those failed replications mean. Is the true effect size smaller than we thought, or are slight variations in method or population responsible for failure? So this is where a closely coordinated replication like a ManyBabies project can help provide insights. The meta-analysis also didn't include control conditions, which raises this really fundamental question about the social nature of these evaluations and what's actually driving infants' choice when they choose a pro-social over an antisocial character. What's behind that choice? So we need more data from control conditions, and so that's where ManyBabies 4 came in. And our overall objectives were to establish a more precise estimate of the true effect size, examine potential moderators, determine whether those preferences are social in nature. And so we followed the ManyBabies approach. We did a large-scale, closely coordinated conceptual replication. So just like the other studies, we didn't do the exact same thing the original study did, but we worked as a team to design the best test of that research question. We worked together really closely to think about what would be the best method, the best approach to test this question. And we agreed on the method before data collection, and I just added this to my slide while Catia was talking, that and the ManyBabies 2 team was talking, that we included authors who have both replicated and failed to replicate the original 2007 findings. So there's a really diverse authorship team, which made for really good discussion. And also contributing to the broader goal of coming up with the broader goal of ManyBabies projects in general, coming up with tools to do these kinds of big team science projects, to advance our theories of how knowledge emerges across different domains and address difficult questions. So here's our timeline. I love this slide. This is Francis back in 2018. So the project is almost going on a decade, because we started having conversations, and probably actually even before 2017, but 2017 was when formal discussions started about bringing ManyBabies 4 to life. We started planning, articulating the research question. In 2018, so this is what Francis is doing here. He's working, Francis is a graduate student at the University of British Columbia, working with Kylie, co-lead of the project. He's actually making those little shapes that you saw in those photos earlier that he packed, and him and Kylie brought them to the infancy conference in 2018. So they made tons of shapes. We hosted a training event at the ICIS conference. And oh, okay, Francis was an undergraduate at that time. Oh my gosh, yeah. So now he's almost graduating. So this is really exciting. He brought all the stimuli. We held a great training. We started doing pilot testing. We started thinking about what the methods were going to look like. We submitted our registered report. The pandemic happened. So things really they were halted. But we were able to keep conversations going. I remember us having conversations over the pandemic, having lots of Zoom calls, talking about what our stimuli was going to be, how to share videos, how to come up with standardized protocols, what does ethics agreements look like. So we were still productive in those years. We submitted that registered report. We wrote it as a group, submitted it to developmental science. It got a stage 1 acceptance, which meant that we were clear to collect data. And we then collected data. We took about a year, which I thought was pretty good, given that this was right after the pandemic. So we collected data in about a year. And then in 2023 and 2024, we submitted that stage 2 registered report. In 2024, it was published. Lots of back and forth discussions with analysis teams, with writing teams, to get to the final product. And to date, what we're working on now is spin-off projects that I'll get to towards the end of the presentation. So I'm going to go through this because our paper is published, so you can read this all online. So I'm moving kind of quickly. What we did was we asked labs, we put out a call for labs. We put out multiple calls for labs. We asked them to test at least 16 babies in each lab between 5.5 and 10.5 months of age. Infants were randomly assigned to a social or non-social condition that I'll explain to you. I've got videos on the next in a few slides. Labs were encouraged to use PyHab. So this is Jonathan Kaminsky, who was a really big part of the ManyBabies 4 project. He developed custom software for labs to use that included the ManyBabies 4 stimuli for habituation design. And so that allowed researchers to present the videos of our stimuli to participants without knowing actually what was going on in those videos. So they would not know if the baby was seeing events in a social condition or a non-social condition. This was our actual sample, the sample that we ended up with at the end. So what we have here is we tested over 1,000 babies. We had a lot of excluded participants. So I was really impressed to see ManyBabies 3 numbers. That's amazing how few exclusions you had. We had a lot of exclusions in ManyBabies, but what was really cool is that we did get a lot of different labs. So these are the different universities here, the different data collection teams, and the number of babies that they contributed. So we had a lot of labs contribute a lot of data, working really, really, really hard. If you look a little bit closer at this excluded participant breakdown, it is worth noting, and just like ManyBabies 3, there's some overlap in categories. So you could be excluded because you had multiple reasons, but a big portion of our exclusion is coming from equipment errors. So there was issues with a lot of our stimuli playback, which I'm going to talk about as we get more towards the discussion. So other things that are important to note are the final number of babies each lab included was about 16, which is great because that was close to what we wanted. That was our goal. We created a lot of materials to make data collection as easy as possible for labs. So we had this big manual that was basically a book that labs could read from start to finish, that an undergraduate student in a lab together with a mentor could really use to run the experiment, to collect the data. We had centralized training protocols. If you were actually the experimenter collecting data, you had to go through one of we had a reliability set of babies where you had to code those babies what choice they made. That Francis put all of this together. So labs had to upload their data before they were cleared for data collection. So we had a really rigorous training protocol. And then what we learned from ManyBabies 1, how difficult it was to combine data once data was collected, even with templates. So so Francis developed a data validator from ManyBabies 4, where labs could upload their Excel files of their data before uploading it to the main project repository, so that they could see if there were errors in the way they entered. Could troubleshoot those things early in the pipeline rather than later in the pipeline. And I think that that's one of the reasons we were able to move so quickly once we finished data collection. So that was awesome that Francis had developed that tool. We also ended up mailing packages, those shapes that you saw Francis making. One of those packages got mailed to Japan. So it was really cool to bring all the labs together in this way through these materials, and actually having something physical from these collaborating labs that you were working with. I thought that was a really cool part of the project as well. So this is the heart of the study. This is the stimuli that the baby saw. So these are the helping events, and I'll play quickly for you the helping and then the hindering, so you can see our version of the stimuli that was filmed. It's filmed stimuli from Kylie's lab of an actual puppet show. So this is helping. Can you hear it? Yeah. So that's helping. Babies saw helping, and then there was a freeze frame, and we measured babies looking to the freeze frame. Once they looked away for a certain amount of time, we cued the next trial, which was then hindering. So this is hindering. This is what hindering looked like. So the same start. Yeah, the music's not important. Some nice classical calming music. It's not annoying. It's nice. And then also, what is important about the sound is that there's some loud smacking on both sides. So when the helping character comes, there's some people can hear. There's a loud smacking when the helper comes, when the hinderer comes, and there's a ding right before the helper and hinderer appear. So those are important audio elements of the event because it signals to babies that an event is actually going to happen. If babies looked away during the critical period, which is that moment of time when the helper is pushing the climber up or the hinderer is pushing the climber down, we replayed that trial. We alternated sequence of events. So babies saw helping, hindering, until they got sufficiently bored, until their looking time decreased a certain amount for a maximum of up to 14 trials. After they saw these events, after they habituated, they were presented with the test phase. So they were presented with those two characters from a video. So remember, they're watching a video screen of these events. Then they're presented with the puppet show. I'm realizing I'm tight on time, so I'm gonna jump. We're basically interested. Also a critical point: the non-social videos were the same, but the climber character had no googly eyes. So now it's a ball being pushed up and down a hill. So we removed that social element. A big shout out to the analysis team. These were some of our central players listed here, especially Yi Wang. Yi worked incredibly hard. Yi was a PhD student at Peking University in China. She's now a postdoc at the University of Chicago. She was hugely instrumental in leading the analysis team along with everyone listed here. And our big question was, do babies prefer the helper over the hinderer? And is this effect unique to the social condition, right? We expect babies to be a chance in that non-social condition where it's a push up, push down character, but in the social condition, we expect them to choose the helper. And what we find is no evidence of a preference for the helper or push up character in either condition, in either the social or non-social condition. So basically, babies are equally likely to choose the helper or the hinderer character. The Bayesian models that we use suggest strong evidence in favor of a null effect here. So babies are at chance. This is a forest plot showing performance across different labs. And so what you can see here is that there's a ton of variability, not just across labs, but also within labs. So each lab here has a row, each color. So green is the non-social condition, red is the social condition. And then there's error bars, and the size of the circle in the middle indicates how many the sample size that lab collected. And so we find lots of variability both within and across labs, more variability within labs. So there's a lot of individual differences. We did a ton of exploratory analyses on possible moderators, including counterbalancing orders, because half the time the helper character was the blue square, half the time was the yellow triangle, different child level characteristics. So we thought maybe handedness would play a strong role because we were measuring manual choice from really young babies. We didn't find that played a role. We also looked at infant looking time. In those moments, the freeze frame happens. Do babies look longer at social and non-social events? We found a slight preference for babies looking more towards social events, which we would predict. But interestingly, it was really stronger in the younger babies. So younger babies showed a stronger effect of looking at social compared to non-social videos. So that was an interesting and unexpected finding. Overall, I'm again going quick because I realize I'm over my time and I want to get to our spinoffs. A big success in, I think what makes the ManyBabies 4 project unique is that we had this behavioral component where we had to interact. Our measure was not more passive, it was more active. We had to actually elicit a behavior from a baby. We had to do it in a really standardized way because there was a human experimenter asking the baby for choice. So I think it's a really nice proof of concept in how to scale up these kinds of behavioral based studies. Showcases the importance of combining large scale replications with meta-analyses for understanding effect sizes, for testing questions. So if we just look at the meta-analyses, sometimes the effect might look larger possibly, though I think Martin has a great paper showing that sometimes they look similar in different contexts, but together they can help us converge on some answers to questions. And then the key thing we're trying to grapple with is that why didn't we find this effect for why didn't we find that infants prefer helpers over hinderers? So we have a couple ideas and we propose these in the paper. One might be that the effect is weaker than we previously thought. It might be absent. It might emerge later. It might be influenced by factors that we didn't measure in ManyBabies 4. And so, you know, this was surprising. This is not what we hypothesized, but it's exciting because it, just like Catia was saying for ManyBabies 3, if not this, then what, right? What has to happen in an infant's first couple of years of life for them to develop the capacity to evaluate others' actions and for that preference for pro-social others to emerge? So this is a question that's being explored through some spin-off projects. to detect it in the ManyBabies 4 paradigm. And so it's important to take this one study in context with a broader literature. So we had many babies in this ManyBabies project, but we only had one paradigm. And so it's worth reviewing what might have happened in our instantiation of this test of this really important question. So I recommend everyone, Brandon Wu just came out with a paper this year in Open Mind that really nicely reviews the broader literature, how to make sense of our findings within that. So I recommend that to everyone. But just want to explore some ideas why we didn't find the effect. Possibly something about the Hill paradigm itself. There's lots of other ways to measure pro-social and antisocial behaviors and infants' choice of one over the other. So one possibility is that there weren't, the paradigm was very simple. But that was also what we intended to do. So in 2022, led by Jonathan Kaminsky, we published a review paper on the value of this kind of simplified stimuli, where we strip away lots of information aside from the key relevant features of a stimuli that we want infants to attend to. But it's possible that babies in this context needed a little bit more contextual information to process the events. And there's a new meta-analysis that a group is working on now. So I would stay tuned to see how our findings fit in line with other work. There might be something also about our instantiation of the Hill paradigm. We really emphasize standardization and experimental control, both within our experiment, comparing across the social and the non-social condition, but also across labs. And maybe that came with some unexpected costs, which I think might be related to some of our high exclusion rate. Limitations inherent to the choice measure. So manual choice is a binary outcome. It's really sensitive to noise and variability. So other types of dependent measures might be able to get more traction on this research question. So I know there's a group right now working on replicating the effect in preferential looking time. I'm not going to read all of these, but a final possibility that's been thrown out too is cohort effect. So the babies we tested in ManyBabies 2, 3, and 4 were all tested really short. What might that mean about how infants are thinking about these things? Key lessons, takeaway, again, because we're tight on time and I want to get to the spin-offs really quickly before our broader discussion. Heidi, feel free to flag me down if you want me just to stop. I see you. So I know we want to have broader discussion. 2 minutes. Okay. So big takeaways, I think some things specific to our project, that we have really nice to spark new collaborations that have tested questions beyond the ManyBabies 4. So I put some screenshots. Hilal Shen is here on the call. I see her. She was involved in the ManyBabies project. She's based in Iceland right now. We have worked together on a variety of projects since starting to work together on ManyBabies 4. So I know lots of pairings of collaboration have stemmed directly from the ManyBabies project. So here are a couple of our recent papers that have stemmed from the ManyBabies collaboration. The project supported standardized protocols. So there's a student from my lab who got a grant from APA to work on ManyBabies. He ended up being a co-author. Yi and Halal led a grant to the Kind Fund Foundation that provided funding for students in India, Turkey, and China. We also have 3 really cool spin-off projects that I can send to people if they're interested, but we'll just highlight really quickly. Individual differences, this is being led by Yi and Halal. A lot of labs collected additional data just beyond that binary choice. So they have survey-based data, behavioral-based measures from videos. So we have a joint book reading task. We designed this book looking at naturally occurring, helping, and hindering pro-social and antisocial events, looking at how caregivers talk about these kinds of events and how that might differ across cultures. We're taking advantage of these videos to code infants' affective responses. So Mira and Laura are leading this, and Francis and Kylie are involved too in these spin-offs as well. Looking at infants' positive and negative and even surprising facial reactions to viewing the helping and hindering events. And then the last spin-off project that we have going on right now is led by Marlene and Robert at Oxford, and they are using OpenPose, which is computer vision software to analyze infants and caregivers' body movements in response to watching the helping and hindering events to see if there's any postural changes. So maybe when those helping events are happening, babies are sitting more upright. And they've got some really cool tools to look at this to see if maybe there was something that our choice measure wasn't capturing. And so thank you to the ManyBabies team, all of our funders, all the real ManyBabies. This is my baby playing with the ManyBabies stimuli. He absolutely loves them. So, and Heidi for all of her support and the general ManyBabies infrastructure. It's been really, really helpful. So excited for general discussion. Thank you.
Great. Thanks so much, Kelsey. It's fun to see your baby here. It was also a true MB4 baby. I remember, you know, the scramble to get the papers submitted before you went out on leave. So
yes, June
that really gives you an idea.
big deadline. Yes.
It was, yeah, a couple big deadlines. Okay, does anybody have any questions specifically for Kelsey before we get into the discussion? I know, you know, we have a lot of topics that we could discuss. So yeah, I'll just open it up. Kelsey, maybe if you want to stop sharing, so that we can
I could also go back. Some of these questions that I put here are kind of general things that the group, the ManyBabies 2, 3, and 4, we're having some conversations over a Google Doc. I think it's a really cool opportunity for us all to be together, but what collectively, right? I don't know if you all felt this way, but listening to the ManyBabies 2, 3, and then 4, a lot of parallel themes. And so thinking about collectively, and I know that's what this conference broadly is about. So if people have idea generally what this means for, take home.
Yeah, maybe just to like kick things off, I'm kind of curious when I look at all of these things, and I know I've talked about some of these things with each of you individually, but maybe I can just pose a question to each set of leads that are here, which is, you know, knowing what you know now with the power of hindsight and what it's like to lead one of these huge collaborative efforts, like what would you do differently, or what's one thing that maybe you, if you were going to do something like this again from the start, that you would do differently? I know that's a big question, but maybe something pops into mind where you've thought like, oh, I wish we'd done X, Y, or Z, you know, 3 years ago. So Toby, do you want to start?
I don't know. What's the other psychological effect that says to keep my reputation, I have to say exactly the same? No, it's maybe test less babies, or the other way around. Maybe we don't need 1,000 of babies to show this null effect. So have a more clever testing strategy. On the other hand, there's this open call and we can't really control, and we are happy for those large samples. That's great. But this is something we are now trying out in our follow-up studies, which are not spin-offs, but we are still getting to the real studies, so to say, in the toddlers. So we try to compartmentalize this into smaller, big team projects to get to our goal faster. I'm a bit afraid that so now from this one registry report, we are branching off into 3 projects. Probably based on these findings, we will branch off into 3 more projects from these 3 projects. And in the end, we are totally confused, but let's see. So this is our learning at the moment. Create smaller teams and try to test fewer participants, but still enough, or let's say more than enough. But yeah, or introduce a stopping rule earlier, maybe.
Yeah, super interesting. I can't imagine anybody, you know, 5 years ago, or, you know, thinking that we'd have a problem of like sample sizes that were bigger than they needed to be, right? That's not a problem anyone in our field is used to having. So that's super interesting. Ingmar, Catia, do you have any thoughts related to MB3?
I would rely on Ingmar for this. I think there's nothing I could have anticipated. I think it went as well as it could be. It was a wonderful experience. I think Ingmar made it a wonderful experience. I think Tobias' point is very valid, but I find that we spend so much time debating and somewhat defending the null effect that having this huge sample kind of works in our favor. So if we didn't, I think a lot of people would question that maybe the sample is just not big enough. So it's kind of this double-edged sword of not really knowing. Maybe the base factors would still be as huge as they are, because maybe that is the only thing that matters. But in many ways, I find that the sample size being as big as it is quite reassuring, that it is as low as you can get. We had Kelsey mentioned, we had to introduce the validator based on other people's experience. That was something that I think was very valuable. But yeah, relying on ManyBabies one was very informative for sure. Sorry, Ingmar, go ahead.
Yeah, no, I totally agree with all you said. One of the things I thought about was, obviously I don't know whether that's different for MB2 and MB4, but obviously no one expected a null result, right? So the aim was always, obviously we're going to establish this effect, and then we're going to test a whole bunch of interesting mediators, right? And to find out what their effects are. So this was sort of the general expectation. And then, of course, to test those, the sample sizes were, pretty good to get age effects and language background effects, all these things. Having the sample size that we have was actually quite appropriate. Maybe it's a little bit too large, even for testing those effects, but for testing those effects across many different countries, etc., it was actually quite appropriate. So, I guess the expectation was different. And then, so the question is, could we have had a different expectation? I think we still need to find out whether that's the case. There's definitely in the rural learning literature, there could be some file drawer stuff going on. There could, so I guess in hindsight we could have made more work of that, and we can still do that, right? That will still be interesting to see, if we do a larger meta-analytic effort, maybe dredge up some of the file drawer papers that are out there on rural learning. Maybe they're there, maybe they're not, but I guess it would be worth the effort to look for it beyond the other spin-off projects that look into more sensitive measures. I think that were mentioned in other projects also, right? So using different types of measures, not binary outcomes as Kelsey mentioned, but more finer grain measures. Of course, they're going to be hopefully making a difference also.
Great.
Those sorts of things.
Yeah, what about the MB4 team? We've got all three leads here.
Yeah, I'll go, and then Kylie and Francis can jump in. I think all these points are great. I think more measures, more paradigms. It's such an effort to get. It's so hard to get one baby in the lab. I canceled my own appointment for bringing my baby into my lab for a study. Like, it's so hard to get one baby into a lab. And so really capitalizing on, once we have labs on board, how can we try to get multiple measures? And so that might mean multiple paradigms to test a similar question, which could tell us something really interesting. We tried really hard to do that with the spinoff project. So we had additional measures, and we had some more qualitative measures, which I think are really valuable and add a lot of richness to the data that we miss when we look at looking time or choice. And so I think just descriptively looking at how parents talk about moral development and talk about good and bad things to their children, how that differs across age, how that differs across culture, is going to be really exciting and interesting to look at. But it was really hard to do that with our sample, because if labs were bringing in a baby, they were trying to piggyback with another study that they had going on probably for that same age range, right? And so I think getting more data points per baby would be helpful. But we did try to do that. We tried really hard to do that. We tried to incentivize that, but and we were successful. Lots of labs contributed above and beyond that original data point, but it was still really difficult. And then I think things that I wouldn't do differently. I really loved the registered report format. I thought it was so wonderful for basically giving some security across almost a decade of work, that at least at the end there'll be something to show for it, even if you don't find what you expect to find. I think that's especially important for junior early career people. There's a lot of barriers to, and I'm sure this is conference at different points, but a lot of barriers. It's really an amazing opportunity for early career scholars to get involved in a project like this, but also barriers in terms of conflicts of interest. And I submitted my tenure packet last year, and I wasn't allowed to list, anyone in the ManyBabies 4 project as a potential letter writer because of conflicts of interest. And so it's really challenging. And so the registered report at least provides some security and also a template for working together because it's really difficult. Not only do you have to come to consensus on the method, but then with infant data, because they can't tell us what they know, you have to come to consensus on how to interpret that behavior, right? And that's really, really hard, especially when you're working with really big teams from different perspectives. So those are some thoughts. And Kylie and Francis and Halal, what you all think too.
Yeah, I can maybe add something. Sorry, my camera's not working. Can y'all hear me okay?
Yeah.
Yeah. I don't know if this is something that we can do differently. But if I were to think about, with the benefit of hindsight, what could be on my wish list if I get to rewind time 7 years back and redo all of this again, I think because we went so hard on the Hill paradigm, I think we ended up with more questions than we have answers. Not whether or not like the Hill paradigm works or anything like that, but rather there's so many other paradigms that others have used in the past to test prosociality and related constructs that it felt like just using one paradigm wasn't sufficient of a test. And I almost wish we had the opportunity to take a more maybe multiversal approach of testing several different things and see whether or not effect sizes fluctuate depending on the medium testing, for example, whether or not it's video versus live shows. I know, although live shows are a lot harder, but also as simple as the myriad different shows that people have used for simple helping versus hindering. So I know that's a bit of a wish list rather than a what could we have done differently, but that's been on my mind since we got the results.
Hey everybody. I have sort of had less opportunity to suggest this in print, although lots of things are in progress. But at the same time as we were failing for ManyBabies 4, my lab was doing a test of 500 babies where we tested them on 50 different common infant cognition tasks from the literature, most of which did not originate from my lab. So we have, I mean, not all 500 babies got through every task, but I would say we have a dozen tasks that are common in the literature that 200 plus babies did. And again, a couple of them are from my lab, but the rest aren't. And babies failed every one. So they failed to show evidence of goal attribution. They failed to show evidence of gaze following. They failed to show evidence of novelty detection. They failed to show evidence of anything. And so for me, I am worried. Oh, sorry. And I should also say that at the same time, we tested some babies online, largely because parents who were involved in the study sometimes chose not to come into the lab during COVID. And thus we had a sort of set of same babies tested in a different environment. And those studies almost, those data points, although they're not as many babies, but as many babies as we used to have in a regular study that we would publish, those babies showed the effects very consistently. And so, yeah, my worry is that all of this is one big cohort effect. And again, all the tasks that we think babies have been doing for decades failed when we tested them in the lab. And so, yeah, I just kind of want to make that point, and that we're working on like many manuscripts to make this point more broadly, but I do, having had this experience, that's my current favorite explanation.
Can you say a little bit more about what do you mean by the cohort effect then? Like what's driving the cohort effect? Is that like the corona, or is that something
Yes.
like
Yeah, sorry. So
Yeah.
I mean, one we're actively like coding things like what choice procedures look like during the pandemic versus, sorry, during and after the pandemic versus now. But basically our experience is that babies are far more anxious in the lab than they were before. It's harder to get them to like be willing to come down the hall with us and participate in a study. And they're much more likely to fuss out, much more likely to refuse to choose at all. So our exclusion rates are higher, et cetera. At first, I thought that maybe this just meant that choice and other behavioral tasks like helping and sharing and all of this kind of stuff would be affected and looking time wouldn't, but that doesn't seem to be the case. So looking time studies in the lab aren't working, but again, same cohort of babies, if they were tested at home online, they were showing the effect. So I actually think that they're freaked out, like maybe the lab's more like a doctor's office to them now or something. It's like a strange situation. And that's what's going on. Like they're just stressed.
So do ManyBabies 4 again at that scale?
So we're doing it not again, but we're doing a preferential looking version where several labs are doing this, but not as many because it was discussed that like getting 50 labs to do it would take another 10 years. But there are maybe 5 labs currently testing both videos of the box paradigm and the ball paradigm, just to try to sample other things over preferential looking to see. Yeah, but I don't, maybe this won't end up being the case, but again, like seeing babies fail at stuff that it's like, developmental psych 101 and they're just failing everything, makes me think that like this is not an effect of like MB3 or MB4, but like an effect of the babies right now.
And are you trying to assess somehow, so I can't imagine how, but to kind of measure their level of anxiety or whatever, or how familiar or
Yeah, so we've looked at temperament, but the only thing we've been able to, we haven't done temperament for like the baby tasks. We've done temperament as well as like naive coders of how shy they seem in the helping and sharing tasks that we've done with toddlers. And both temperament and how shy they seem in the lab are predicting their lack of helping and sharing. We've had a like 75% drop in helping and sharing rates post-pandemic. So it used to be like 75% of our kids would help and share, and now it's more like 20% of the same age, like same lab, where we have pre-COVID and post-COVID data. And again, yeah, it's predicted by their parent-reported temperament and how shy they seem in the lab. But we haven't done that for the babies.
Both intriguing and scary.
Yes.
Have you considered, so one thing that we discussed in MB3 also was, we just take much more care in, preventing confounding variables in stimuli, for example, and also in standardizing test procedures. So I think, let's say, the practices around, standardization of tasks and preventing confounding factors in stimulus materials and all sorts of things have improved over the years. But so, when it comes to, let's say, auditory stimuli, language-like stimuli, if you take out some of those confounding factors, they become also, the stimuli become, you could say, less natural, but also they become less multimodal. Let's say, and you focus on a single aspect of the stimulus that you're focusing on, syllables in the case of rural learning, right? But then the intonation contour is not there anymore, where it may have been the case in the original stimulus. So all these types of, let's say, standardization forces could also be making tasks more difficult. So I'm not sure whether that applies to some of the other tasks you were mentioning, but that could also be
Some of them for sure, I think, but definitely not all of them. So,
Sure.
Like the Woodward task, for example, was done I started doing the Woodward task as an undergrad. That's how I got started, and we did it exactly the same. So in person, a person's arm reaching in from the side, grabbing this thing over that thing. And 250 babies, no effect. Yeah, depressing. Yeah. But I think you're right more generally. I mean, both, we want to improve our science, right? And do fewer bad studies that had confounds that explain away the results. And we also, it's like a happy medium between real world and control, and yeah.
All right. Thank you so much to everyone for these contributions. It's been fun hearing about these projects sort of together, and to get to hear this sort of crosstalk between the project leads about what it's been like running these huge projects. I look forward to continuing to puzzle through what this all means and where we go next with all of you. You guys are what makes ManyBabies such an amazing community. So thank you so much, and we'll end here. Thanks, everyone.
Thanks for organizing.